Hello students, today we will study Theorem 6.2. This is the theorem of Standard 10 chapter number 6 triangles. So what is the statement? Statement is if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third line, right? So this is the theorem 6.2 and it is a converse of the theorem that we have studied as a basic proportionality theorem, theorem 6.1. In this theorem we have not given that the line which intersect these two sides of a triangle, that is DE, is not parallel to the third side BC, right? Here there is a triangle ABC and DE is the line which is intersecting side AB into D and AC into E. But here we have just said that the same ratio, the line is parallel to the third line. We have to prove that this is DE is parallel to third line BC, right? Okay, so whatever we have given, let us first of all write down. We have given that the same ratio, these two sides are divided into the same ratio. So here we can write down that AD upon DB is equals to AE upon EC. Now here we cannot say that the DE is the parallel line, that we have to prove, and the line is parallel to the third line, right? To the third side. Here we have to say third side of the triangle. Okay, so let us take that DE is not parallel to BC. DE is not parallel to BC. Let us take one more line DE dash, that is parallel to BC. So let the line DE dash is parallel to BC. Now this, if DE dash line is parallel to the line to the third side BC, then according to the basic proportionality theorem, here we can write down that AD upon DB is equals to AE dash upon E dash C. Why? Because here we are considering that DE dash is the line which is parallel to BC. Okay, so from given, whatever we have given is AD upon DB is equals to AE upon EC, give it equation number 1. And here, whatever the ratio is, give it equation number 2. Now see, AD upon DB is also equal to AE upon EC. AD upon DB is also equal to AE dash upon E dash. So from 1 and 2, we can say that, we can write down that AE upon EC is equals to AE dash upon E dash C. Both these ratios are equal. What is the meaning of this? The meaning of this is that E dash and E, here we have shown that E and E dash are the different points, but according to this condition, we can say that E and E dash, both the points are same. Both the points are same. So here we can write down that E and E dash are the same points. That means whatever the line DE that divides the two sides in the same ratio is must be parallel to the third side BC, right? So this is whatever we have to prove. We can say that DE is parallel to third side Understand? See, first of all, we do not take that DE is the parallel line. That we have to prove. That is why we take another line, that is DE dash. That suppose that DE dash is the parallel line to the BC. So according to the theorem, we can write down AD upon DB is equals to AE dash upon E dash C. According to the theorem 6.1. Right? Now when we compare whatever we have given with this, we can see that here we get both the point E and E dash are the same points. When E and E dash are the same points, then both the lines are DE dash and DE. Both are the same line. That is why DE will be the parallel line to the third side BC. Okay? Now let us study the example number 1, which is based on this theorem. Okay. What is the question? Question is, if a line intersects AB and AC of a triangle ABC at D and E respectively and is parallel to BC, prove that AD upon AB is equals to AE upon AC. See, here we have given that DE is parallel to BC. Same situation we have given here is that there is a triangle ABC. One line DE intersect AB at a point D and AC at a point E. And we have also given that DE is parallel to BC. DE is parallel to BC. So we have to prove that AD upon AB, that means AD upon total side is equals to AE upon total side. This ratio is equal. That we have to prove here. So now here we know that DE is parallel to BC. DE is parallel to BC. Then according to the theorem 6.1 basic proportionality theorem, we can write down that as line DE is parallel to line BC. We can write down that AD upon DB is equals to AE upon EC according to the theorem 6.1, or you can write down that according to the theorem of basic proportionality theorem, right? We can write down this thing here. Okay, now here see, whatever we have to prove is AD upon AB is equals to AE upon AC. Here numerator is same but the denominator is different. So can we write down this ratio? We can also write down this ratio in this form, that DB upon AD is equals to EC upon AE. Right? Now you may wonder that why this is possible. See, if we have the ratio, let us understand by taking an example. Suppose we have a ratio that is 3 upon 4 is equals to 3 upon 4, because both these are equal, so we can take the equal. Now what will happen if we interchange the numerator and the denominator? We get 4 upon 3 is equals to 4 upon 3. Now we can see that both the ratios are still equal, because whatever is the digit in the numerator in both the sides is the same, and whatever digit in the denominator is also same. So when we interchange both these numbers, it is not change the ratio. The ratio will remain the equal. So here we can write down that dB upon AD is equals to AEC upon AE. Now let us add 1 both the side by adding 1 both side. Okay, what will happen if we add 1 both side? We get dB upon AD plus 1 is equals to EC upon AE plus 1. Right? Here what we do is we add 1 both the side. Now take the LCM. Here when we take the LCM, we get the AD is the LCM, is the numerator, sorry, is the denominator. Now dB will remain as it is. Here 1, we have to multiply this 1 with the AD. AD. In the same way here also AE will be the denominator. In numerator this EC will remain as it is. Here we have to add the AE. So now see what will happen. AD plus DB plus AD. DB plus AD in the total side AB. So here we can write down AB upon AD is equals to EC plus AE. EC plus AE, that means the whole side AC. AC upon AE. Right? So now you can understand that why we add this one to both the side. The reason is we want to get the total side. So when we add one to both the side, we get the total side here AB and the total side AC. But see here what we have to prove, that is AD upon AB upon AE upon AC. So let us again interchange like we do here. So when we interchange this, whatever we get here is AD upon AB is equals to AE upon AC. Right? So this is the result we get whatever we have to prove. So see, in this way, this is the one another result we can use in the next sums that we are going to solve. Right? This is also the result. See, we can take AD upon AB, this portion upon total side is also equal to this portion AE upon AC total side. So this is one another result we can use as the same that we are using here, that AD upon DB is equals to AE upon EC. Right? Okay. So this is what about theorem 6.2 and example 1. Okay. This is all about this lecture. Thank you.